Hello friends, good evening. Welcome back to the session. Today we are going to discuss about very interesting topic which is related to AI powered image generation. So with a given input, the images can be generated. Sounds interesting, right? So we're going to discuss. These are our agendas. So if we want to describe these things, we can describe it like if we will give our text input. Okay, if you provide some text input like whatever the text input may be, and from that the image, whatever the image we want, we can describe that image in the text format. Okay, after doing this, we have a text encoding. In the text encoding, whatever the tool we are using, okay, there are different tools from where we can convert the text form into the image generation format. Okay, so whatever the text we will provide, that will be converted into the numerical representation. Okay, so that is called as text encoding format. After that, there will be an image generation. In image generation, the AI uses its knowledge of text image relationship between the two, and it will learn from the data set to generate an image that corresponds to the encoded format or encoded text. Okay, so basically what we are doing, whatever the image we want or whatever the image we have described through our text description, that text description will be converted into the text encoded format, and through our image generation tools, these text will be then have some relationship between the AI uses its knowledge and task to make a relationship between the text and the images, so that whatever the encoded text we have provided, it will generate the image according to that. Okay, so there is first tool, which is stable diffusion. Stable diffusion is an advanced deep learning model that transforms the textual description into the detailed image. Okay, then this stable diffusion produces a varieties of output, which are ranging from realistic portraits, landscapes to abstract compositions. See here, it is written, given one example like the teddy bear wearing suit discussing a business proposals around the office table. And within this toolkit, this is a text we have given. Okay, and then this is AI powered tool, which is a stable diffusion tool, which will convert this text into the encoded format, and then it will make some relationship between the text and the image format, and then generate the output as an image. Okay, so it has been generated, the output. Then this stable diffusion was first released in 2022 and is funded by relatively new search and development, which is R&D company called as Stability AI. Stable diffusion is an open source tool. Okay. Then stable diffusion first reduces the image to a more manageable latent space. Doesn't uses the same pixel space of the image. It first try to reduce the size of the image. Okay, to make the more manageable latent space. This will dramatically reduces the processing needs, which is allow you to run the model on desktop as well as on the laptops through our GPUs. Stable diffusions may be fine-tuned to match your individual requirements with a very few of like 4 or 5 photos using a transfer learning architecture or transfer learning models. If we want to use this toolkit for our own purpose, we can use it for like 4 or 5 photos. We can use transfer learning and we can use this toolkit, okay, to generate the outputs. Then There is stable diffusion architecture. So stable diffusion models, rather than working directly in the huge image space, the image is first compressed. We will first reduce the size of the image. Okay, we'll compress the image size using, so that it will take some lesser latent space. Okay, the latent space is substantially smaller, allowing the model to run more quickly and effectively. This strategy simplifies the process and improves the model's efficiency. Then there is variational autoencoders. In variational autoencoders, we have encoder-decoder architecture. In encoder, what will happen? Encoder will compress the image size, and then it will convert the image size, whatever the compressed image size has been generated, it will convert into the encoded or latent format, latent space format, or what we can say numerical format. After that, the decoder will restore the image. It will restore the image from the compressed form. Okay. Then there is forward diffusion. Forward diffusion will gradually introduce Gaussian noise into a image until only random noise is left. The final noisy image cannot be used to identify the original image. Okay. Then there is one term called reverse diffusion. Reverse diffusion is a parameterized process that iteratively reverses the forward diffusions. Okay. Then there is noise predictor. Noise predictor used for denoising image. Okay. It will estimate noise in a latent space. It will subtract it from the image through multiple iterations based on user-defined steps, whatever the user-defined steps has. This process is guided by conditioning the prompts to influence the final image output. Then there is text conditioning. Text conditioning involves text prompt, which we will provide. Okay, processed by the clip tokenizer to create 768 value vectors. Okay, it uses up to 75 tokens in a prompt. In one prompt, we can have 75 tokens. Okay, so the text encoder will then send the prompt to the unit noise predators like a text transformer. Text for a transformer has encoder decoder architecture, right? So it will send it like transformer architecture, which will adjust the random number generators, which will generate different latent space images. Then there are several applications where we can use the stable diffusion. Okay, it will help researchers visualize difficult data. Okay, where there is difficult data, we can use it or visualize for a difficult data. Then game developers can create assets straight from the textual descriptions. E-commerce companies can visualize products designed based on descriptions. It can generate a diverse array of images, including photorealistic scenes, abstract compositions, as well as portrait and landscape styles. It can also be useful for stable diffusions, inpainting or outpainting elements within an existing image. Okay, as well as what we can say image to image translations. It can use for that also, image to image translation. Inpainting is the process of filling in missing or corrupted parts of the image. It is common task in image restoration and editing, and it can use to remove objects from the image. Okay, like repair damaged photos, or it can be used for complete incomplete images. Outpainting is the process of extending an image beyond its original borders. It can be used to create larger images, and it can add new elements to the image or change the aspect ratio of an image. Okay. Then image to image translation is the process of mapping an input image to an output image. It can be used to change the artistic style of an image. It can use for changing the appearance of the objects in an image also. Or it can be used for improving the quality of an image by increasing the contrast colors or by increasing the color density likewise. Okay, so these are all the applications with respect to our stable diffusions. Then there are some, obviously this is one tool, stable diffusion. So there are some advantages and limitations with respect to this toolkit. Okay, so this has advantages. It will improve the stability and quality compared to the traditional techniques. Yes, it can improve the stability as well as quality of the image. Whatever the quality will get, it will be more than that of the traditional techniques. But limitations is computationally intensive and time consuming. Since we are giving the textual format and then trying to generate the image, it will be time consuming process. And it generates high quality image from a low quality sources. Yes, it can result and limitations are results can vary depending on the inputs and parameters. Whatever the prompt we are giving, it will depend on that prompt that whatever the output will be generated. Okay, based on our prompt, our text, the result will be dependent. Enhancing the specific features in an image. Yes, we can enhance the specific features. If you want to highlight some features in this, so we can use that for this purpose also. Then it is not suitable for all editing tasks. It removes the unwanted elements. Yeah, for all editing parts, it cannot be used. And what are the advantages then? Works for both static and dynamic images. Okay. And limitations is it requires specialized hardware and software that can be expensive. Okay. Then it saves time and effort compared to the manual editing. Manual editing will require time. Yes. Like time consuming it is, but lesser than that of the manual edit. May not be suitable for all types of images. For example, low contrast or noisy images, it cannot be used. Okay. So our second tool is our Midjourney. Midjourney is a high quality used simple text-based prompts. Okay, here also by giving some simple text-based prompts, we are producing the high quality photos. Then there is closed source tools which runs on the proximity codes. Okay, is only accessible via Discord bot. It can be used for easy prompt. Each prompt which generates 4 images. Okay, it employs diffusion process. Yes, the Midjourney platform provides 2 unique elements to improve the image generation experience. First is our upskill and second is our variations. So in upskills, our Midjourney tool generates image that can be upskilled for better resolution and finer details. Okay, upskill. And variations. In variations, it can explore several interpretations of the prompts, allowing for creative inquiry and diverse outcome. In variations, from the given prompt, it can have a different, like several interpretations from the prompts and generate according to that. Then, to effectively engage with Midjourney, adhere to the following guidelines. First is our sign up process. Begin by creating an account on Discord, which is a comprehensive communication application that's accessible by both web also and as a desktop also. Then joining Midjourney. It will navigate to the Midjourney Discord server and locate a room designated for the newcomers. Then crafting your prompts. It will utilize the image command within a chat to submit a descriptive text prompt for the image you wish to create. Then there is image generation. Midjourney will then produce 4 unique images in response to your prompts, each tailored to your specified concepts. Exploring further, we'll have a preferred images to either upskill or for variations. For upskilling, what we have to do for enhanced detail or for generating the variations for various creative explorations. Okay. Then there is how it works, how Midjourney works. So the specific details of Midjourney's backend infrastructures are not publicly available, as the company keeps this information confidential. We can understand the core principle behind its operation. So we are giving the prompt processing and vectorizations. User enters a text prompt. Okay. After that, our LLM, which is a large language model, will analyze the prompt. Whatever the prompt you as an user have given, the LLM model will analyze that. It will extract the key information and potentially generating a vector representation. Vector representation is a numerical form of whatever the text we have given. It will take that and captures that in a vector store format. Okay. After that, there will be a generator networks. The vector representation is fed into the generator network. Okay, whatever the vector store or whatever the text format we have converted that text format through our LLM to a vector encoded format. Then this vector encoded format is then fed to the generator networks. This network is aimed to produce an image. Okay, this network generator will then stores all the vector stores or vector representation values which we have provided there. Okay, and it will take that and it will generate our image. It will then closely resembles the desired outcomes described by the prompt and the vector stores. During the training, the generator might initially attempt to estimate the noise, whatever the noise present in the real image based upon the training data. Then substantially, it progressively refines the generated image by removing the estimated noise. What is the estimated noise has been there? It will remove that noise from the whatever the image is there, whatever the image it will generate generated image, it will remove the estimated noise from there. Potentially, it will utilize some techniques like upscaling and convolutional layers for doing so. So this is all the working process of Midjourney. Then after doing this generator, okay, after removing the estimated noise from the generated image, our discriminator will generate whether it's a real image or it will discriminate between the real image or the fake image. Okay, so whatever the fake thing will be there, it will remove as a noise. Okay, it will remove as a noise, and it will the generated image and the real image from the training data set are fed to the discriminator. Okay, whatever the generated images formed through our generated network and the real image, what is the actual real image, is then fed to the discriminator network, and then it will generate whether it's a correct form or not. Then this network acts as a critic. It will attempt to distinguish between the real and the generated image. Okay, and then it will again give a probability score as well. Okay, it will indicate its confidence in classifying the image as a real or a fake one. Okay, then there is adversarial training. In adversarial training, what we will do, both the networks are trained simultaneously in the adversarial manners. like generator also and discriminator also. Generator will try to create image, and it will then feed, it will then fool the discriminator by minimizing the discriminator's ability to correctly classify them as a fake. So eventually what will happen, generator will add noise in the image. Generator will add noise in the data so that it will try to fool the discriminator between the real and the fake image. But discriminator learns accurately because the discriminator has been trained on the training data as well. So discriminator then learns accurately distinguish between the real from the generated image by maximizing its ability to correctly classify them. This ongoing computation then derives both the networks to improve, ultimately leading to the generators to produce increasingly realistic and high quality images. Okay. So this is our architecture, or what we can say working of our mid-journey. Okay. Then there is last step left, that is a user interaction and refinements. Okay. So in our mid journey, might presents the user with several initial image variations, which will be generated by the network. It will use, the users can provide a feedback through choosing a preferred variations for upskilling or further refinements. It will offer additional prompts or descriptions to the guidelines, to the guidelines of generation process. Okay. So here what we are doing, we are adding the noise. Noise addition is happening. The generator will add some noise in the image. See, this is the noise. We are adding that purposefully. Okay. And discriminator, as in police officer, it will try to distinguish between the real and the fake images. Okay. So that we will get the high quality image. So this is all our mid journey tool is all about. Then there is advantages and disadvantage of this mid journey tool. So ease of use. Ease of use is relatively, it is user friendly interference, but in disadvantages, limited control and understanding. Then there is image generation. So it has powerful and visually stunning images. But disadvantages, it can be biased and diversity issues can be there since we are adding noise in the data. So then there is style customization. Wide range of artistic styles are there. And disadvantages, public domain images. Applications are, it can be used for marketing, design, content creation. It can be used for all these purposes. Okay. And disadvantages, it can be used for limited customer supports and privacy concerns are also there. So this is all about a mid-journey architecture. Then there is CLIP, that is contrastive language image pre-training model, which is developed by, which is a multimodal learning architecture, which is developed by OpenAI. CLIP is a neural network which is trained on varieties of image text pairs. CLIP, which is contrastive language image pre-training, is a cutting-edge AI model which is developed by OpenAI. It bridges the gap between the visual and textual data understanding. Okay. It will utilize a constructive learning approach to align the images with its corresponding textual description. Okay. Then it has been trained on several range of internet collected images and text. It is capable of understanding and generating the images from natural language descriptions. It offers significant improvements in zero-shot learning capabilities. Okay, like if we are giving a prompt of zero-shot, it can give us the output. Okay. Then there is, it can be used for, it can be applicable in various domains such as computer vision, natural language processing, and much more. how it works, how clip works. So clip consists of two main components. First is a text encoder and image encoder. Okay, so our text encoder processes the textual inputs into the embedding format. As we all know from the starting itself, we are understanding whatever the text we are providing, that text are then converted into the numerical format. That numerical format can be, we can call it as latent embeddings, we can call it as latent vector store, we can call it as embedding. Okay, so whatever the text in whatever the text we are getting, input text, that is then converted into the some numerical formats. Okay, and suppose we are getting some image also. Okay, in clip we are having image also. So then in the image, whatever the input we are getting as an image, that is converted into the usual embedding formats. Okay, like pixel formats it can be converted. Both the encodings are trained to the projects, the text and images into the shared embedding space. Okay, and then it uses a large scale data set of image as well as text pairs of training. Okay, like we have taken one original image and we have taken the augmented positive image. Okay, and after that, this is an augmented image. Okay, so we are taking that image and we are using that image, and we are saying that if it making a same similar action or not, making a same dissimilar, and then we are classifying it as an image. So here, since we have given the augmented image, it is giving a negative image, not giving a positive response. Okay, so it is showing it as a tiger, which is not a correct one. So it will again go forward. This will employs the constructive learning to match the corresponding text image pairs amongst a batch of negative pairs. This model is optimized to minimize the distances between the correct text image pairs, a correct image versus correct image text pairs. Okay. Then it will maximize the distance between non-matching pairs. What are the max? It will maximize the distance between the non-matching pairs and minimize the distances between the matching pairs, so that we can identify that and give the label according to that. So it will leverage a large corpus of text and images without manual labeling. Okay. Then it will utilize a transformer architecture for both text and image encoding format. So this is our clip architecture. So clip architecture, here we'll have a text encoders. Text encoders is based on a transformer based model which will optimize for textual inputs. And then there is image encoders. In image encoders, we are using a vision transformer, that is VIT, or ResNet based models for image inputs. Okay. These are the pre-trained models which are available, foundation models we can say. The shared embedding space allows for the comparison of textual and visual data. The comparison of textual and visual data. Both the encodings are trained simultaneously to learn the alignments. Okay. After that, the model is trained on a diverse data sets to ensure robustness and generalizability. Then we are using a zero-shot learning capability STEM from this generalized embedding space. After that, we are using an architecture which supports the various image resolutions. It will use a scalable to different data set sizes and complexity. It will then fine-tune options are available for specified applications. Like if you want to use that specific for a fine-tuning that model, we can use it. Then it will emphasize the importance of a balanced data set to avoid the bias. Okay. If there are like bias towards certain class, we will emphasize the balanced data sets to avoid the bias between the data. data sets. So these are all the applications with respect to clip. Okay. Then this is the zero shot learning. It will enables the image recognitions in categories. It wasn't explicitly trained on using textual descriptions. Okay. Then it will have a image search. It will allow searching for images using natural language description. It will improve the accuracy over keyword-based searches. It will have content moderations. It will help in identifying and filtering the appropriate contents in the images by understanding their context through text. And then there is augmented reality interactions. Okay. And in the last application is a usual question answering. This can be used for even question answering also. Okay. Like answers question about images. Suppose understanding both the visual as well as content. So it when the user's text will be there, it will give a accurate responses to that. So this is it for today, friends. We'll meet in next lecture and understand about the applications of clips and other parts. This is it. Thank you for joining.